Okay, today we're going to talk about some quadratic word problems. And what we use is called a vertical motion formula. Let me double check to make sure that's what it's called. The vertical motion formula, yes. And what that formula is, h of t equals negative 16 t squared plus v times t plus h of 0. So there's a bunch of variables in here, and we can actually determine what these variables are supposed to be. And so the h of t, change my color here, this h of t is the height of an object at any given time. The t that you see at the squared and then with the vt, that is time. V is your velocity, how fast is your object moving, and h of 0 is your starting height. Sometimes our objects start at the ground, sometimes our objects start in the air off of a cliff or a diving board or out of a window. But the negative 16 is always there. That has something to do with our gravity, I think. But this is the vertical motion formula. This is what we will use, or what we would be given, and then we'd have to either factor this or find the vertex. Those are basically the only two things we will do with this equation. We're either going to factor it or use the formula to find the vertex, which is negative b over 2a, and then go back and plug in. So usually what we have is we have an object. My object I'm going to use is a rocket. Okay, so my rocket is going to take off, and when it goes up, my rocket comes back down. And if you notice, it takes on a parabola shape. And so the questions that they're going to ask you are, they're going to ask you, how long does it take for that object to get to its maximum height? Then they're going to ask you, what is the maximum height? They're also going to ask you, how long does it take the object to hit the ground? Or if you're jumping into the water, how long does it take for you to land in the water? So those are some of the questions that you're going to see. Or if you're dunking a basketball or anything like that. So this top point here is my vertex, which we already know that. We've studied vertex, and we know how to find vertex. You use negative b over 2a, and then you plug that value in to get the y-coordinate of the vertex. And so when you're dealing with word problems, this negative b over 2a represents the time it takes for your object to get to the maximum height. So how long does it take the rocket to get to the maximum height? You would simply do negative b over 2a. Then they're going to ask you, well, what is the maximum height? Well, that would be whatever you got when you plugged in your axis of symmetry. So maybe your rocket only went 3 feet in the air, or maybe your rocket went 100 feet in the air. You'd have to use the given equation. And they may ask you, how long does it take for that object to return back to the ground? So if they ask you, how long does it take for the object to hit the ground or land in the water or something like that, that means you need to find the x-intercepts. And the x-intercept could be found by factoring. It can be found by using the quadratic formula. Or it can be found by using completing the square. These are all things that we have studied on how to solve a quadratic equation. So factoring is probably going to be used often here. If you can't factor this, then you probably would want to use the quadratic formula. Completing the square, it's fun and all, but sometimes I think we lean more towards quadratic formula. All right, so you're going to be looking for either the vertex or the x-intercepts. And to find the vertex, we know negative b over 2a. and then you plug that in. So you have to read the question carefully to see what part are you looking for, the time, the maximum height, or when it hits the ground, the water, what that x-intercept value is. So either vertex or finding the intercept. That's it. That's all you're going to look for. And what's really nice about word problems are you can give decimal answers. Okay, up until this point, we've been simplifying radicals using complex answers and things like that. So note, we are going to give our answers in decimal form. Yay. No more simplifying radicals. That means you can take this entire problem and shove it into the calculator and get your answer in a decimal. You don't have to worry about simplifying the radicals. All right, but again, that's only for word problems. So let's take a look at some examples. Remember, we're going to be finding the vertex and finding the x-intercepts, but we have to make sure we find the piece that it's looking for. All right, so flipping our page, we can see some problems here. First one talks about Jason. He's on a vacation with some friends. He's jumping off a cliff into the ocean below. So if you want a visual, here's Jason. He's going to jump into the shark-filled waters below. Hopefully not. And so they're going to probably say something about how long does it take for Jason to hit the water, and they're going to ask about how high did Jason go. Part A, look at that. How long did it take for Jason to reach his maximum height? So we're looking for time it took him to get to his maximum height, which we know is the vertex, which if you remember from the notes on the other page, the maximum height is my vertex. And of course, I've got my time, comma, the maximum height. Oops, maximum height. So I'm looking for the time, so I need the negative b over 2a. So in my equation, you're given this equation, negative 16t squared plus 16t plus 480. So I'm going to negate my b, which is negative 16. 2 times negative 16 is negative 32, so that is 1/2. It's going to take him only 1/2 of a second to get to his maximum height.
There will be no baseball workouts today. Also, there will be no basketball workouts today. Thank you.
Part B, we're looking for what is the maximum height that he reached. So we know it took him 1/2 of a second to get there, but how high did he actually go? So we're going to take my 1/2 and we're going to plug it into the equation that was given. So negative 16 times 1/2 squared plus 16 times 1/2 plus 480. So when you grab a calculator nearby and you plug that in carefully and you simplify that, you get 484 feet. Make sure you put your units on these because they are word problems. You want to make sure that it makes sense. Part C, Jason hits the water after how many seconds? So this is what we talked about earlier on the other side. We're going to talk about hitting the water. So we're going to solve this. We want to figure out the x-intercept. We need to find out this point down here. And to do that, we're going to either factor, use the quadratic formula, or complete the square. I'm going to try factoring it because I think factoring can go a lot faster than the quadratic formula. All right, so if you take a look at this equation, got some big old numbers here. So I want to see if I can reduce this equation first. And I think I can divide by 16. I also like my t squared to be positive, so I'm going to divide by a negative 16. And so when I do this, I get t squared minus 1t minus 30. So you can check that, put that in your calculator. And so I need to solve this. I'm going to set it equal to 0, and I'm going to factor this. It's a trinomial. So I'm going to ask what times what gives me 30, and at the same time those two numbers would give me a negative 1. The answer is going to be positive 5 and negative 6. So positive 5 times negative 6 is negative 30. Positive 5 take away 6 is negative 1. It all works out. So now I'm ready to split my equation or my factors up, set it equal to 0. So when I move my 5 over, I get t equals negative 5. Move my 6 over, and I get t equals 6. Well, you have to make sure your answer makes sense. If I ask you how long did it take Jason to hit the water, are you going to tell me negative 5 seconds? No, you can't have negative time. So my answer is 6 seconds. Make sure your answer makes sense. And you would have gotten the same thing if you would have done the quadratic formula. All right, number 2, a toy rocket is launched vertically upward from the ground level with an initial velocity of 128 feet per second. Then its height after seconds is given by this equation. So I've got my equation. Obviously, I don't have a C value because it's starting at the ground level. How long will it take for the rocket to hit the ground? So we know if it's talking about hitting the ground, so I had my rocket, started at the ground level, it went up, it's coming back down. I'm looking for this point here. So I can either factor it, or I can use the quadratic formula, or I can solve this by completing the square. And I think I can factor this one pretty easily.
Dale Davis, come to the timeout window. Trenton and Dale Davis, come to the timeout window.
All right, so I can, let's see here, negative 16t squared plus 128t. I believe my GCF is negative 16t. Again, I like negative, so I can make that t positive. You didn't have to take out a negative 16. So what I've got here is negative 16t is my GCF, and when I divide, I get positive t minus 8. Okay, so all I did was factor out a GCF, and again, you could have used the quadratic formula here, where a is negative 16, b is 128, and c is 0, and plugged it into the quadratic formula. Just figured factoring was a nice little review here. Set these equal to 0. When I divide by negative 16, I get t equals 0. When I move my 8 over, I get t equals 8. So this is obviously 0 and this is 8. So my rocket took off at time 0 and then it landed at time of 8 seconds. So my answer I'm going to choose is 8 seconds. Because 0 just means it hadn't taken off yet. Part B says, after how many seconds will the rocket be 112 feet above the ground? So 112 feet, I'm just guesstimating, is about here. That means my rocket hits 112 feet on its way up, and it hits 112 feet on the way down. So how could I determine the time it takes to get to those two positions? Well, I can plug in my height at any given time. So h of t is 112 equals negative 16t squared plus 128t. To solve this, you need to set it equal to 0, and then you can factor it, use the quadratic formula, or complete the square. Doesn't matter your method. You would still end up with the same answer, excuse me. All right, so I like to have my t squared positive, so I'm going to say 16t squared minus 128t plus 112 equals 0. So all I did was move my t squared and my t term to the left to make them positive t squared. Now I can factor this, and I believe I can divide. I'm going to try by, let's see here, 16. I'm going to reduce this problem because right now it's pretty big. So I get t squared minus, that gives me 8t, and this gives me positive 7. So t squared minus 8t plus 7 is factored. Now, not factored, it's reduced. Now I'm ready to factor. So I get t and t. What times what gives me 7 and adds up to a negative 8? Well, that would be negative 1 and negative 7. That multiplies to give me a positive 7 and adds to give me a negative 8, so that's pretty good. Split and solve. When I move my 1 over, I get t to be 1. Move my 7 over, and I get t to be 7. So we've got 1 second and 7 seconds. And that makes sense because on my drawing, you're going to hit the 112 feet on your way up and on your way down. So I'm going to put seconds here, and I'm going to squeeze and 7 seconds. So 1 second and 7 seconds. Part C, how long will it take for the maximum to get to the maximum height? So vertex, because anytime it says maximum height, you're going to think vertex. Okay, maximum height is your vertex. So I want to know how long it's going to take. So I'm just looking for the time part of it, which is negative b over 2a, and that's from your notes. So negative 128 over negative 32 is 4 seconds. So it takes 4 seconds to get to the maximum height. Part C wants to know, what is that maximum height? Well, to figure out the maximum height, I simply take my axis of symmetry I just found, which is 4 seconds, and I plug it into the given equation. So negative 16 times 4 squared plus 128 times 4. And when I pull my calculator out and I plug all that in, I get 256 feet. So if you see the word maximum height, think vertex. You're going to calculate the vertex. If it says anything about ground, you're going to factor or quadratic formula or complete the square. If it's not factorable, you're going to have to use the quadratic formula. All right, so let me see on the next page. This is the next page. So again, all you have to do here is read this. On number 3, they give you the vertical motion formula, and they want you to simply plug in your numbers. You got a 101-foot cliff and a velocity of 116, so you would just simply plug those in for v and h of 0. And then it tells you here to use the quadratic formula, probably because it's not factorable. So you would use x equals negative b plus or minus the square root of b squared minus 4ac, and then round your answer to the nearest second. So you guys can try that one and see what you end up with. So you can pause the video and then unpause the video, and you will have an answer. So part A would be h of t equals negative 16 t squared plus 116 t plus 101. Part B, you would have used the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, when you're here, you can plug this whole thing into your calculator, whether you're using Desmos or if you're using the calculator that you downloaded, Graph and Calc, which is awesome. To do this, you would do alpha y equals, and you want to choose that first option that says n over d. That's numerator and denominator. And what that does is it gives you this fraction bar. So you can type in your numerator, which was negative 116 plus the square root of 116 squared minus 4 times a times c, arrow down, and do the 2 times a. Again, that is alpha y equals, so you can get your numerator and your denominator, and you can plug the entire quadratic formula into your calculator. Now when I hit enter, I get a negative answer, which we know we can't have negative time, so that's not even a possible solution. So what I can do is I can arrow up to the equation again and hit enter. And this time we know that the quadratic formula has that plus and minus right here where I'm at now. So I'm going to change that to a minus sign. And then I'm going to hit enter. And my other option is 8.0 seconds because I believe this problem said round to the nearest of a second. So if I go back to my word problem, again, we had negative 0.79, which is not a solution because we can't have negative time. And then when I got my other answer, I got 8.0, and that's seconds. So that would be my answer there. So when you're using a calculator and you're using the quadratic formula, just put the whole thing into the calculator. And if you're using Desmos, you can do the same thing. You just hit the fraction bar and it gives you your numerator and your denominator. Number 4, you're looking, let's see here. You are given an equation and you have a friend and you're trying to figure out if you guys can throw the grappling hook high enough. So because you're trying to see if you can throw it high enough, it says maximum height here. So what are you going to look for? That's right, you're going to find the vertex. So the vertex, remember, is negative b over 2a. So that's positive 32 over negative 32, which is negative 1. And so I need to take that negative 1 and plug it into my equation, which to me, negative 1 does not make any sense because it's supposed to be your time, and you can't have negative time, but we're going to proceed with this problem anyways. And so when I plug this in, I get a height of 21 feet. And you had to be able to throw the grappling hook at least 20 feet because that's how high the ledge is above you. So the question is, can you throw it high enough to reach the ledge? Yes, because you were able to throw it 21 feet in the air. All right, so I am going to let you guys complete the rest of these problems. Take a picture of them and then upload them, and I will check them for you to make sure that you are correct. And if you have any questions, please don't hesitate to email me or send me a message, and I will see what I can do to help you. Again, if it says maximum height, use the vertex. If it says hitting the ground, you are going to factor or use the quadratic formula. Quadratic formula, plug it into a calculator because we are allowed decimal answers. Because we are working with word problems, we want decimal answers and not radical answers. All right, I will see you guys next time. Bye.